Hello student, good morning. I am Dr. K.SINHA, Professor of Chemistry. Today I will continue from the last class. Last class I have started new topic, that is the liquefaction of gases and critical temperature. Under that I was discussing question, answer and explanation based on Joule-Thomson effect and inversion temperature, and somewhat miscellaneous question related to this topic. Now I will continue from the next question, that is question number 76. I have discussed up to question number 75. Now I am reading the questions. Two substances with the same reduced pressure and same reduced temperature will have the same reduced volume. This is called what? First option, Gay-Lussac law. Second option, law of corresponding states. Third option, law of reciprocal proportion. Fourth option, continuity of a state. Again I am reading the question. Two substances with the same reduced pressure and the same reduced temperature will have the same reduced volume. This is called, first option, Gay-Lussac's law. Second option, law of corresponding states. Third option, law of reciprocal proportion. Fourth option, continuity of a state. Just to think, this question is little difficult. If you have studied in advance, already I have discussed while reviewing the chapter and also before discussing the complete chapter. Again I am reading the question. The two substances with the same reduced pressure and the same reduced temperature will have the same reduced volume. This is called, first option, Gay-Lussac's law. Second option, law of corresponding states. Third option, law of reciprocal proportions. And fourth option, continuity of a state. Think, you can answer it within 10 seconds if you have studied. Its correct option is that is the question. Two substances with the same reduced pressure, the substances with the same reduced pressure and the same reduced temperature will have the same reduced volume. This is called, what is called actually? This is called continuity of a state. Okay. By definition of law of corresponding states. This is according to the definition of law of corresponding states. Hence option D, continuity of a state, that is the correct. Okay. Now next question I am reading. A relation between vapor pressure and temperature is known as, first option, gas equation. Second option, Clapeyron equation. Third option, Clausius equation. Fourth option, Clausius-Clapeyron equation. Again I am reading the question. A relation between vapor pressure and temperature and temperature is known as first option gas equation, second option Clapeyron equation, third option Clausius equation, fourth option Clausius-Clapeyron equation. Just to think, if this is a difficult question, this is also advanced study I have discussed. If you have attended, then you can answer it. Just to think. After that, I will tell the answer and explanation. Now, I am telling you answer. Its correct answer is Clausius-Clapeyron equation. Clausius-Clapeyron equation. Actually, this is the relation between vapor pressure, not only pressure, vapor pressure and temperature. A relation between vapor pressure and temperature is known as Clausius-Clapeyron equation. Not only Clapeyron equation, not only Clausius equation. All are different. Its correct answer is Clausius-Clapeyron equation. Both are scientists. They have derived this equation. And this option D is correct. Clausius-Clapeyron equation. What is actually this? Then actually this is also you can tell by the this what is given a statement only on that a relation between vapor pressure and temperature. Actually this relation was given by two scientists, that is a Clausius and Clapeyron, and that equation is known as actually this is the Clausius-Clapeyron equation. That equation is known as Clausius-Clapeyron equation. Hence, option D is correct. Now, next question I am reading. A gas X causes heating effect when allowed to expand. This is because first option, the gas is noble gas. Second, the inversion temperature of the gas is very low. Fourth option, the gas is ideal. Fourth option, the boiling point of the gas is very low. Again, I am reading the question. A gas X causes heating effect when allowed to expand. This is because first option, the gas is a noble gas. Second, the inversion temperature of the gas is very low. Fourth option, the gas is ideal gas. Fourth option, the boiling point of the gas is very low. This you can answer within 10 seconds. Just to think. It is a conceptual. You can answer it. Think it. Its correct answer is the inversion temperature of the gas is very low. Okay, that's why any gas, simply gas X is given, then X causes heating effect when allowed to expand. This is because the inversion temperature of the gas is very low. If gas inversion temperature is low, then it will cause heating effect. Okay. Now, heating effect is shown by those gases which have low inversion temperature. This is actually main reason. Now, next question I am reading. Which set of conditions represents easiest way to liquefy a gas? Which set of conditions represents easiest way to liquefy a gas? First option, low temperature and a high pressure. Second, high temperature and low pressure. Third, low temperature and low pressure. Fourth, high temperature and high pressure. Again, I am reading one more time. Which set of conditions represent easiest way to liquefy a gas? First option, low temperature and high pressure. Second option, high temperature and low pressure. Third option, low temperature and low pressure. Fourth option, high temperature and high pressure. This question you can answer in 5 seconds. Just to think. Its correct answer is low temperature and high pressure. Already I have discussed that just to live any gas, if you want to liquefy, then you have to cool it, and after when you will reach to the critical temperature, that time you have to apply the pressure, high pressure. Then first option is correct. So that is the A, low temperature and high pressure. A gas can be easily liquefied at low temperature and low temperature and high pressure. Now next question I am reading. The behavior of temporary gases like CO2 approaches that of permanent gases like N2, O2, etc. as we go. First option, below critical temperature. Second option, above critical temperature. Third option, above absolute zero. Fourth option, below absolute zero. Again I am repeating the question. The behavior of temporary gases like CO2 approaches that of permanent gases like N2, O2, etc. as we go. First option, below critical temperature. Second, above critical temperature. Third, above absolute zero. Fourth, below absolute zero. Again you listen the question. The behavior of temporary gases like CO2 approaches that of a permanent gases like N2, means nitrogen gas, oxygen gas, etc. as we go. First option, below critical temperature. Second, above critical temperature. Third, above absolute zero. Fourth, below absolute zero. Just to think, this is a little tough. Just to think. After that, I will tell the answer and explanation. Its correct answer is above critical temperature. Correct? The behavior of temporary gases like CO2 approaches that of a permanent gases like nitrogen, oxygen, etc. as we go above critical temperature. Correct? Why? Now I am telling you. Temporary gases cannot be liquefied above critical temperature. This is the main reason. Temporary gases. Then carbon dioxide gases, temporary gases. Correct? Then temporary gases cannot be liquefied above critical temperature. Above critical temperature. Okay? That's why its correct answer is above this temporary gases like CO2 approaches that of permanent gases. It will behave like a permanent gases like nitrogen and O2 as we go above critical temperature. Okay, this is the correct answer. I told you critical temperature for nitrogen and oxygen is very low, minus 210, minus 160 degree, like that way. And CO2, its temperature, critical temperature is more. Obviously, if you want to make that is a positive, these are negative. These are negative. Then if we, how they will be have carbon dioxide, CO2 gas, like a permanent gases N2 and O2, then above critical temperature, behavior of both will be the same. Hence correct answer is option B. And next, actually, nitrogen gas, oxygen gas, these gases are called permanent. Why permanent gases? Because temperature is very low. Then you will not get that temperature easily. Hence, always you will find you will get these gases everywhere. Everywhere you will get these gases, because only after that low temperature its a phase will change. And before this it will be have like a gas only. That's why it is called permanent gas. But ammonia gas, sulfur dioxide gas, NH3, all are the temporary. Hence, if you apply high pressure, then this can liquefy. But there, N2 and O2, nothing will happen if you will apply high pressure, because you have to bring you have to cool it up to the that critical temperature. That is not so easy. Next question I am reading. The relationship between PC, BC and TC is, here you should know PC means critical temperature, and PC means critical pressure, BC means critical volume, TC means critical temperature, C means critical. Okay, the relationship between PC, BC and TC means critical pressure, critical volume and critical temperature is, 4 option is given. First option, PC, BC is equal to RT. Second option, PC into BC is equal to 3 RTC. Third option, PC, BC is equal to 3 upon 5 RTC. And fourth option, PC into BC is equal to 3 by 8 RTC. Again, I am reading the question. The relationship between PC, BC and TC is, first question, PC into BC is equal to RT. Second, PC into BC, that is equal to 3 RTC. And fourth option, PC into BC is equal to 3 upon 5 RTC. Fourth option, PC into VC is equal to 3 upon 8 RTC. This question is little tough. Okay. If actually already I have discussed this relation, if you are remembering, you can answer it within 10 seconds. Already I have discussed it. Now you think. After that I will give answer and explanation. Its correct relation is PC into VC is equal to 3 upon 8 RTC. PC into VC means critical pressure into critical volume is equal to 3 upon 8 RTC. R is gas constant, TC. This is the correct relation. Okay. The relation actually, this is actually relationship. The relationship between critical constant is also called critical constants. PC, BC and TC are called critical constant. Critical constant already discussed. At a critical temperature, what pressure you have applied, that is called critical pressure. And that time, what was the volume for 1 mole of gas, that is called critical volume. Means all are at critical point only. At critical point, what is the temperature? That is the critical temperature. What pressure have been applied at critical temperature? That is the critical pressure. And what was the volume for 1 mole of gas? That is the critical volume. Then these are also called critical constant. Then all three critical constants are related by PC into BC is equal to 3/8 RTC. So you will get it by derivation. Okay, derivation is there. Now we have to remember this. While solving the numericals also, this will be used. Because two value will be given. PC, BC value will be given. R value is constant, you know. R value is fixed. Then TC value can calculate. Hence, fourth option D is correct. Now next question I am reading. The constant A in van der Waals equation is maximum in first option helium, second hydrogen, third oxygen, fourth ammonia. Again I am reading the question. The constant A, small a, in van der Waals equation is maximum in first option in helium, second option in hydrogen, third in oxygen, fourth in ammonia. Already I have discussed this answer also. This type of question I discussed. Here a small a, that is telling about the attraction, intermolecular attraction, a small a. Okay, now you think. After that I will give answer and explanation. It's a correct answer is ammonia. Its correct answer is ammonia. See, all these three gases, helium, hydrogen and oxygen, they have low critical temperature. Already I have discussed. Only option D, ammonia gas is temporary gas. Correct? Ammonia. Its correct answer, that is a forces A. The constant A. The constant A in the van der Waals equation is maximum in ammonia gas. In ammonia gas, a small a is maximum for NH3 out of the given gases. Okay, intermolecular forces are more in ammonia gas in comparison to helium gas list. That's why all are gases, that is you can say free due to the low interaction. Least interaction is in ammonia gas, not ammonia gas, helium gas, least interaction. Okay, then oxygen gas also, hydrogen gas also, attraction is less, but in ammonia that attraction is more. Attraction is more. Correct? That's why it is easily liquefied. It is easily liquefied, but their attraction is very less, all three gases. Hence it is difficult to liquefy. Okay. Now one more question I want to discuss. Last question, today's last question. The cooling caused by expansion of a compressed gas below its inversion temperature without doing external work is called. First, Joule-Thomson effect. Second, adiabatic demagnetization. Third, Tyndall effect. Fourth, Compton effect. Again, I am reading the question. The cooling caused by expansion of compressed gas, which below its inversion temperature. The cooling caused by expansion of compressed gas below its inversion temperature without doing external work is called Joule-Thomson effect. Second, adiabatic demagnetization. Third, Tyndall effect. Fourth, Compton effect. Okay, just think, in 10 seconds you can answer it, less than 10 seconds, just to think. Its correct answer is Joule-Thomson effect. This is actually definition. No explanation is required. Correct? The cooling caused by expansion of a compressed gas. Gas was compressed and you have allowed to expand. Then it has to not do any work. Quickly it will expand. Okay? And it will, because energy will be lost by the system. Hence, cooling will be, it will produce cooling. Okay? Then cooling caused by the expansion of compressed gas below its inversion temperature without doing external work. For in this case, no work will be done. Work will be not done because it was under pressure. Now you have removed the pressure, then no work will be done, and it will produce compression. System will become cool because work is done. Here, because it was under the pressure, that time work was done when it was compressed. Now when you are removing the pressure, then gas will expand, and that gas what was required, pressure what was required when it was compressed, that actually temperature will be now utilized, and it will produce cooling. Cooling will be produced. Why? Because when it was compressed, that time work was done. Now if you are now releasing the pressure, removing the pressure, hence you have to not do any pressure, and because it was high temperature, now it become low temperature, means cooling effect will be there. Then cooling caused by the expansion of a compressed gas below its inversion temperature without doing external work is called Joule-Thomson effect. Okay. Now this is according to the definition of Joule-Thomson effect. Today I am stopping only here. Next class again I will continue. Thank you.